Well, good afternoon. Today we're going to be looking at piecewise and quadratic functions. We discussed functions in the previous couple of classes. Remember, we said that a function is an algebraic expression or a rule that assigns each number in one set to exactly one number in the other set. That first set is called the domain, the second set is called the range. And for piecewise and quadratic functions, we'll start off with just piecewise functions. A piecewise function is a function that has that's defined using more than one piece. So I'll say a function defined using more than one piece. Okay. And for a piecewise function, to really understand what I'm saying, we just have to look at an example, okay? So go into our homework, and starting, I think it's with number 2. For the piecewise function, find the given values h of -7, h of -2, h of 3, and h of 5. Let me write the problem down first. This is number 2. And the function is h of x equals... We'll use the piece -5x minus 17 for x values that are less than -6. We'll use, I like this. This is a constant piece here. The y value will just be 3 for x values between -6 less than or equal to x less than 3. And let me write it down, then we'll discuss what that inequality in red that I'm writing down is saying. And we'll finally use the piece x plus 4 for x values greater than or equal to 3. And I may as well write down, what do they want? H of -7, h of -3, h of +3, and h of 5. Let me switch over to my writing. There. This function is an example of a piecewise function. Notice it has 3 different pieces. The piece that you use depends on the x value you're using. Remember, for any x value, there can only be one y value. So for h of -7, we know how function notation works. That says go to the function, wherever you see an x, replace it with -7. But we have to decide which piece we're going to plug that -7 into. In this case, let's see, our x value is -7. Is -7 less than -6? Or is -7 between -6 and +3? Including -6, but not including 3. When you see this compound inequality here, the thing with 2 less thans, That's saying that the number x is between -6 and +3. You would use this red piece if x equals -6, but you don't use the red piece if x is 3. Use the green piece for any x value greater than or equal to 3. So before you decide to start plugging in, you have to ask yourself which inequality is satisfied. And you look to do that, you look at the x value and come back over here. Is -6 less than is -7 less than -6? Is it between -6 and +3? Or is it bigger than +3? Which inequality is satisfied by the x value? Well, let's see. We'll start with an easy one. Is -7 bigger than 3? No, okay. Is -7 between -6 and +3? No, I think the only inequality that's going to be satisfied is this first one. -7 is smaller than -6. So you plug the -7 into the blue piece. So you have -5 times -7 minus 17. -5 times -7 is a +35. Minus 17 gives us a y value of 18. So h of -7 is 18. Now the next one, they want us to find h of -3. Okay, you have to decide which piece you're going to use. Is -3 smaller than -6? Is -3 between -6 and +3? Or is -3 bigger than +3? Okay, the second one, -3 is between -6 and +3. So, I like this. We're using this part right here. What's the y value going to be? Is there a variable to plug in there? No, it's just a constant 3. So for x values between -6 and +3, the y value is just a 3. Looking at the third one, h of 3. Okay, so the x value is 3, or x value is 3. Is 3 less than -6? Is 3 between -6 and +3? Does that include 3 there? Look at that inequality. Is 3 being included? No, so it better be this one. 3 greater than or equal to 3. There's the one that allows x to equal 3. So we're using the green part. We go to the green part, we replace the x with 3. So we have 3 plus 4, which is equal to 7. And I should have been circling my final answers. The last one, they want h of 5. h of 5. Which piece will we use? Is 5 less than -6? Is 5 between -6 and +3? Or is 5 bigger than 3? Bigger, so it's that green one again. Replace the x with 5. So we have 5 plus 4 is equal to 9. Any questions on my logic? We're doing two things with piecewise functions today. We're evaluating them and we're graphing them. Now, evaluating, you have to decide which pieces. You can't just go and, -7, I'm going to plug it in everywhere I see an x. No, only one piece can be satisfied, and that one piece is determined by which inequality is true for the given x value. Any questions there? Okay, let's punch in our answers. So we said h of -7 was 18. You said h of negative 3 was a positive 3. H of positive 3 was 7. And one more. H of 5 was 9. Before we go on, I think I'll make up a couple more just to see if y'all actually are following this. Suppose I wanted h of 0. I'm going to make up some problems. Let me switch over. Okay, so this is not part of the problem. I'm just continuing with that function h of x. Suppose h of 0. Which piece would I use? Blue, red, or green? How do you decide? I think you're going to use the second one. 0 is between negative 6 and positive 3. 0 is between negative 6 and positive 3, so what's the y value going to be here? 3, okay. What about, I'll make up one more. How about h of, let's say negative 10. What's my x value? My x value is negative 10, okay. Which piece is satisfied by negative 10? Is negative 10 less than negative 6? Is negative 10 between negative 6 and positive 3? Or is negative 10 bigger than positive 3? The first one. Okay, so I think y'all are getting the hang of this. I've got to say, I think this is the smallest class I've ever been up here recording. I only have 4. It's a cool rainy day here in Corpus Christi, and there's only 4 students in this big room, which is sort of strange, I guess. So 50 minus 17, what am I getting? 33? Any questions there? We're doing 2 things with piecewise functions. We're evaluating them. And the key to evaluating them is just deciding which piece is satisfied, which inequality is satisfied by the given x value. And the second thing we're going to do is graph them. To graph piecewise functions, we're going to graph them just by plotting points. But we're going to plot points intelligently. We're not just going to start randomly choosing numbers the way I was doing right here and the way they were doing up here. We'll make however many pieces there are. We'll make a little table of values. There's not a piecewise graphing tool built into this course, so the graphing part will be handled with multiple choice problems. We'll draw the graph and then we'll look at the 4 choices and choose the picture that looks like the graph that we drew. So with that in mind, hold on. I'm going to skip to one that illustrates everything I want to illustrate. There, okay. We want to graph. This is a 3-piece function. This is number 6. We want to graph f of x equals, I'm writing the problem down. We'll use 2 plus 2x if our x value is less than negative 4. We'll use the piece addressed negative 2 times x if x is between negative 4 and positive 5, including positive 5. And we'll use the piece 3x if x is greater than 5. Let me make sure I didn't miscopy that. 2 plus 2. Okay. switching over to my paper. There are 3 different pieces, so we're going to make 3 different tables of values. Let's see. My graph paper ready. I'm going to call these numbers where the intervals change cut points. For lack of a better number, I'm going to call them cut points. Notice the red piece. The red piece changes to the green piece at -4. So we have a cut point at -4. The green piece is going to change to the blue piece at +5. So we have 2 numbers serving as cut points, -4 and +5. When you're drawing your graph, you're going to want to make sure that that you clearly label -4 and +5 on the x-axis. And does anyone want a piece of graph paper? I have graph paper, or are you going to freehand it? What do you want? You're freehanding? Okay. Okay, I'm drawing myself a big XY grid. Oh, goodness, there. Okay, you have to make sure, what were those cut points? -4 and +5. Make sure you clearly label 1, 2. There's -4 on the x-axis. 1, 2, 3, 4. +5 on the x-axis. The numbers that are the cut points, the numbers on the inequalities, that's what you need to clearly label on the x-axis, because that's where the red piece will change to the green and the green will change to the blue. We're going to plot points, as I said, but we're going to plot the points intelligently. We're not just going to randomly start choosing numbers to plug in. Y equals 2 plus 2x. Y equals -2x. And y equals 3x. If we were just going to graph those things, what would we expect? We sure wouldn't expect to get a parabola, because a parabola doesn't just have an x, it has to have what? A quadratic function would have to have what appearing on that variable? A square, that's right. These are just lines. Y equals mx plus b. So how many points do we need to draw a line? Just 2 points to draw a line. So for the red piece, as I said, we're going to plot points, but we're plotting them intelligently. The first number that you will always want to use when you're plotting these things is any cut point that appears in the inequality. So for the red piece, you have to start off at -4. Oh, but look at that. Remember your rules for labeling solution cut points with the cut point method. Can't x actually equal -4? On the red piece, can x actually equal -4? Is there equality there on that red piece? No. So to indicate that you're plugging in a cut point for which there's no equality, you're going to have to use an open circle. We said that we needed 2 points to draw a line, so we need another x value. Now, generally, my favorite number to use for x is 0, but I can't use 0 on this red piece. I have to choose a number that's actually less than -4. Here we are. There's -4 on the x-axis. I need a number over here to the left of -4. How about -5? Choose an x value that's smaller than -4, so we'll use -5. Realize the x values that you choose on your own must satisfy the inequality. So the numbers, those secondary numbers that you choose yourself, must be regular closed dots. The only time I'm going to have a an open point, an open circle, is when I plug -4 into the red piece. And there's one other down here for the blue piece. There's no equality. I'm going to have to use 5 in a moment, but since there's no equality, I'll have an open circle there as well. But you should have dozens of open circles floating all over your graph. The secondary points you find are just regular closed dots. Let's plug the -4 into the red piece. Plugging -4 into the red piece, we get 2 plus 2 times -4. Well, 2 times -4 is a -8. So we have 2 plus -8. What's that going to give us for y? -6, I agree. Plug in -5. You'll have a 2 plus 2 times -5. That'll be a 2 minus 10. So we have a y value of -8. So we're going to go to the graph. We have 2 ordered pairs to plot. -4, -6. 1, 2, 3, 4, 5, 6. There's -6. And I'll need -8 also. Let me move all that up. So we have -4, -6. We're going to have an open circle at -4, -6. Our secondary point was at -5, -8. So right there, remember the inequality. Remember the inequality we're trying to graph. We're looking at the x-axis where it's less than -4. So it starts at the cut point. It starts here. And it goes towards the secondary point. Does this interval x less than -4, does that end? The x-axis less than -4. Does this interval out here ever end? No. So the left side of the graph doesn't end. It just keeps on going. Oh, wait. There it is. Oh, that's not a very good... Is that part of a line? It's actually an open ray. Has an open circle as a starting point, and then the line going in one direction. We'd call that an open ray. Now the second piece. We got to make a table for the green piece. I like this green piece right here. X, Y. I like this because there's really no choice. I know which numbers I must plug in for X. Any cut point that appears in the inequality has to be plugged in. So we're going to plug in a -4, and we're going to plug in a +5. Are those cut points going to be open circles or closed circles? What do we look at? There was no equality here, so that cut point was open. But what about these cut points? I see equality, so both of these are going to be closed circles. Any questions on my logic? So we're going to plug -4 into the green piece. That's -2 times -4. That gives me a +8. Plug 5 into the green piece. That's a -2 times 5, what are we going to get here for the y value? Negative 10, okay. Oh, let me write there, negative 10. So we have two ordered pairs. We have negative 4, positive 8. Uh-oh, let me count up. Oops, I've lost 1, 2, 3, 4, 5, 6, 7, 8. Okay. So at negative 4, 8, we're going to have a regular closed dot. At positive 5, we're going to be down 10 units. Let me mark that. There's negative 10. So at positive 5, we're going to be down 10 units. Negative 4, positive 8. Positive 5, negative 10. And I have a question. Are we going to have any arrowheads on this piece? Do y'all think we're going to have any arrowheads on this piece? Look at that inequality. Does it keep going and going to infinity or negative infinity? Remember how I've read that? That says x is between negative 4 and positive 5. So in this case, with the compound inequality, you're going to have a definite starting and stopping point. Oh, wow. That's pretty good. Normally it's so wavy like this thing here, but look, that was a pretty good line segment. Any questions on my logic so far? In a moment, once we're through with this graph, we're going to discuss why are we plugging in these numbers like the blue piece. We're about to graph the blue piece. What's the first number I'm going to plug in for x? 5, even though x can't equal 5. Why are we doing that? We'll discuss that in a moment. So let me make myself another little table of values. We need an x value that's bigger than 5. We need the x to be 5 with an open circle. Notice there's no equality. We've got to use the cut point 5. No equality, open circle. And we need an x value bigger than 5. What do you think we should use? Oh. Well, okay, so what do y'all think I'll use? A number bigger than 5. 6, yeah, that sounds like a good number to plug in. Now, is 6, are we going to have an open circle here? Is 6 a cut point? Do you see the number 6 appearing up here with these inequalities? No, so any number you choose on your own must be a regular closed dot. Just like this 5. You chose that 5 as a number smaller than negative 4, so a regular closed dot. Same thing here. Plugging in 5 for the blue piece, what are we going to get? 3 times 5 is 15, I agree. Plugging in the 6 into the blue piece, what are we going to get? Plugging 6 into the blue piece, what are we going to get? 18, I agree. And now I'm going up here. I'm going to the graph. We're starting at 5:15. Oh, goodness. I think I guess I should have dropped this graph down more. I'm going to have to go up 15 units. Oh, and 18. Well, here's 15. Oh, that's terrible. Right there is 18. So I should have just free-handed this after all. We go to 5, 15. We have an open circle. open circle at 5:15, and then at 6 we go up 18 units. Notice that's just a plain blue dot. So let's see, right there, I'm going to start. I start at the cut point. Hey, is this graph going to have a arrowhead? If so, it starts here, it goes there, it can't go past the cut point. So if it's going to have an arrowhead, it'll be over here on the right hand side. What do y'all think? Will there be an arrowhead? Will that interval, x greater than 5, does that thing ever stop? No, so the graph keeps on going forever. Any questions there? I should have lowered my graph more. Isn't that terrible? Hold on. There, at least the whole graph fits there. Any questions? On which one? A closed circle? Oh, any number that you choose on your own. You chose that 6. You needed a number bigger than 5. You needed a number that was bigger than 5, so we chose 6. Is 6 bigger than 5? Does it satisfy the inequality? Yes, it does. If you're using a number that satisfies the inequality, you use a regular closed dot, just like this one here. We chose a number on our own, -5. Is -5 smaller than -4? Yes, it is. So, I suppose the better question isn't why is it closed. I suppose the better question is why are these other points open? That means you're using a number for x that doesn't satisfy the inequality. If you're choosing the number on your own, it must be a regular closed dot. The only time you can have an open circle on the graph is if you're plugging in a cut point for which there's no equality. You're plugging in a cut point for which there's no equality. And it goes back to another, this brings up a good point. If x has to be bigger than 5, why did I even use 5 right here? The real number system is said to be dense. Between any two real numbers, there are infinitely many other real numbers. When I look at this graph, there's 5. I claim there are infinitely many numbers right here to the right of 5, right out there. To the naked eye, they would look like 5. For example, 5.00001. Suppose I wanted to use that number for x. Realize, isn't that number bigger than 5? 5.0001 is bigger than 5. So that point needs to be on the graph. If you plug it in here, you're going to get a 15.00003. $5.15 is not on the graph, but if I told you come up here and plot the point 5.00001, 15.00003. If I told you to come up here and point at where that is on the graph, you'd come up here and you know what it would look like you were pointing at to the naked eye? Wouldn't it look like that point where we have that open circle? That open circle is saying 5.15 isn't on the graph, but there are plenty of other points that look like 5.15 that are on the graph. Any other questions? I think I'll just freehand my graphs now. I think I'll freehand my graphs for the next one. So let's graph another piecewise function, and let's see. Oh, wait a minute. We didn't choose the correct answer, did we? Uh-oh. Okay, y'all looking at the picture? Where is that graph? Here it is. I'm going to start blowing these things up. Is this it? A? No, that middle segment there is in the wrong direction. B? No. Okay. C? No. I think they've reversed those left and right ends. It better be D. Let's look. Where's my mouse? I can't even see my little mouse now. Do y'all see it? What is going on? Where's my mouse? Do y'all see it? Well, it's on. Move it around. Oh, I see it. There. It better be this one. Is that it? Yes, that's the graph. So I'm going to say response D. There. Any questions? Now, let's do number 4 before we do number 3. I like number 4. Let's do number 4 before we graph number 3. Let me write the problem down. Oh, this only has 2 pieces. F of x equals, we'll use the piece -3 minus x if x is less than or equal to 1, and we'll use the piece -4 plus 2x if x is greater than 1. Okay, let me switch over to my paper. There. Okay, what's my cut point? Where is the red piece going to change to the black piece on the graph? At 1, I agree. The cut point's going to be at 1, so you got to make sure you clearly label 1 on the x-axis. There are only 2 pieces here, so we're only going to need to make 2 tables of values. Okay. And clearly label 1 on the x-axis. We're going to make our red table of values. What is the first number we must plug in for x? We have to plug in that cut point 1, I agree. Look there, I see an equal sign. So are we going to have an open circle or a closed circle on the red piece? Closed circle, I agree. Now choose an x value that's actually smaller than 1, a number that satisfies that inequality. Could I use 2? No. 0? Okay. 0 is less than 1. The secondary numbers that you choose on your own must satisfy the inequality, so the secondary numbers are always just closed dots. So plugging in 1, we get -3 minus 1, which is -4. What are we going to get when we plug in 0 into the red piece? Okay, -3 minus 0, I agree with the -3. So at 1, we go down 4. So at 1, we go down 4, closed dot. And then at 0, we go down 3. another closed dot. You always start drawing at your cut point. Here's the cut point. The graph starts going in this direction. X less than 1. Does that interval ever stop? It's at 1. It's going to the left. Does it stop? So the left side of the graph can't stop. That left side, put on the arrowheads. And now the black piece, what's the first number we must plug in for x? We have to plug in 1, but is equality okay there? Can x actually equal 1 in this black inequality? No, so we're going to label it with an open circle. Now we need another x value, a number that's actually bigger than 1. What do you think I'll use? 2? Now 2 is bigger than 1. Remember I said any secondary points that you choose on your own have to be regular closed dots. Plugging 1 into the black piece, we get a negative 4 plus 2 times 1. That's negative 4 plus 2, which gives me a y value of negative 2. Then we're going to plug in a positive 2. That's a negative 4 plus 2 times 2. Negative 4 plus 4, what's that going to give us? 0? I agree. We're plotting points, but we're plotting the points intelligently. We start off with the cut point, and then we choose an x value that satisfies the inequality to get our secondary point. So 1, negative 2, we go down, we have an open circle there at 1, negative 2. Then 2, 0, right there. Starts at the cut point, it goes to that secondary point you chose. Does it stop? No? So I'll put my arrowheads. I should warn, with this multiple choice option, they may not show the arrowheads. They may just continue drawing the thing until they run out of room, okay? But we should be able to pick out the correct response. Any questions how I made those tables? Okay, A, B, C, or D. Let me stop. A, no, that's not it. Is it B? That sort of looks like it, isn't it? I think it's B. Let's compare the others. C? Definitely not. I agree. D? So response B. Any questions there? One more graph at number 3. Number 3. Okay, let me graph the piecewise function. F of x is equal to, it's 2 pieces, x minus 2, if the x value is less than or equal to negative 3, and we use just negative 5 if x is greater than negative 3. So we'll make our 2 tables of values. We'll start off with the black table. Oh, but by the way, y equals x minus 2 and y equals negative 5, they're just lines, so we only need 2 points to draw the graph. What do you think I'll use as my first x value on the black piece? What will I plug in first for x? Negative 3. You've got to start with the cut point to get the starting point of the graph. Now, is this cut point going to be an open circle or a closed circle? Closed, because there's equality. Now we need an x value that's actually smaller than negative 3. Could I use 0? No, 0 is not smaller than negative 3. What do you want to use? A number to the left of negative 3 on the x-axis? Negative 4, okay. And remember, any number you choose on your own must just be a regular closed dot. Plugging in negative 3, we get negative 3 minus 2. What's that going to give me for y? Negative 3 minus 2 is negative 5, I agree. What about negative 4 minus 2? Negative 6, I agree. So, I didn't ask y'all, what number is the cut point? Where will my pieces be changing? The cut point is negative 3. That's where the black piece will change to the red piece. So at negative 3, we go down 5. 1, 2, 3, 4, 5. There. We have a closed dot. The second point, negative 4, negative 6. So we go left 4, down 6. There's my second point. You start drawing at the cut point. You go towards the secondary point, the one that you found, that you chose on your own. Does the graph stop? No, x less than negative 3. That starts at negative 3 on the x-axis. It keeps going on towards the left. So the left side of the graph will have an arrowhead. Any questions on that part? Now the red piece, that's the interesting piece. What's the first number I must plug in for x? I have to plug in negative 3, open or closed? Open. I need another x value that's bigger than negative 3. Could I use 0? You know, 0 is my favorite number to plug in. Could I use 0? Yeah, I could use 0. 0 is bigger than negative 3. I'd rather have $0 than be $3 in debt. So, and this is nice. There's no variable to plug in. I know what number is going to go in both of these places. What is it? Negative 5. Oh, by the way, the 0, negative 5. Is that going to be an open circle too? No, it isn't. The points, the numbers that you choose that satisfy the inequality have to be regular closed dots. So we go to negative 3, negative 5. Here it is. Hey, wait a minute. I already have a closed dot there. If you have both an open and a closed dot appearing on the graph at the same spot, closed dots take precedence. That open dot says negative 3, negative 5 isn't on the graph, but yes, it is. It's on the graph because of the black piece. So, I remember they used to do this. They'd have the open dot around the closed dot, but the book doesn't do that anymore. It just starts there and go, oh, there. Oh, well, I think I'm making it worse.
It's supposed to be a horizontal
It's a horizontal ray, not a line, horizontal ray. It's an open ray, but in reality, what I would do is just one dot. If you have an open and a closed dot appearing on a graph at the same ordered pair, the open dot says the point isn't on the graph, but yes, it is. It's on it for the black piece. So closed dots take precedence over open dots. A, B, C, or D. Oh, that's it. No.
Not A.
B? No. C? C's looking promising. What do y'all think?
Notice each mark is 2 units because the way it says 10 here. So 2, 4, 6, 8, 10. So 3 would be -3 right here.
I think that's it.
I think that one's in. I'll click on the 4th one just so you can say it's not that one obvious.
I think they reversed the pieces, did it? The response, 3, and C. Any questions there? Okay, we've discussed piecewise functions. Now we're going to discuss quadratic functions. Let me write this down. Is it still raining outside?
Yeah.
Okay, let's switch.
Oh, we're going to go on to another problem.
Number 9, but we need to discuss.
I know.
Oh, you want to do this?
Oh.
Here, I'll let you do it. Earlier this semester, we graphed. First assignment over graphing dealt with some graphing tools, and y'all had some that were where you were using the tool 3-piece quadratic tool. Yes. We're going to have a different quadratic tool, different quadratic tool, but first of all, before we use that, we already know what quadratic means. It means there has to be an x square in it. And so, you can't have a bigger exponent than x squared. So we're going to write a function that has an x square in it in its equation. And the graph of this type of function is called a parabola. It's a U-shaped figure that opens up if the number a is positive. So if a is positive, it opens up. If a is negative, the graph opens down. So parabolas open up if a is positive, they open down if a is negative. Just like with the quadratic formula. A is the coefficient on x squared, b is the coefficient on x, and c is the constant. You need to make sure you have it written in the standard form, just like when you're writing or working with a quadratic formula. Every parabola has a turning point, which is called the vertex. That turning point, if the parabola is opening upward, that turning point is the low point on the graph, and we're going to call that minimum. That's where the minimum value, that's where the smallest y value occurs. Could y'all guess that M word I'm going to write over here by this one? If the parabola is opening downward, what are we going to call this point? The vertex is the maximum. If you're going to graph a parabola, we have to know that vertex. And we're going to have something called the vertex formula. also called the axis formula.
I usually wait until I state that to draw in the axis, but okay. And here it is. Do y'all remember have y'all memorized the quadratic formula, I wonder? And if you don't have to have it completely memorized. Do you remember how it starts? It starts negative b, then plus minus square root of b squared minus 4ac all over. Do y'all remember what the bottom part of the quadratic formula is? 2a. This formula gives us the x-coordinate of the vertex. As my brother said, it also tells us something called the axis, and the axis is a vertical line that cuts the parabola in half.
If you could pick up that paper and fold it down that vertical line, the right side of the graph should be the mirror image. It should lie right on top of the left side.
Now, you'll notice we're only looking at functions. And with functions, they've got to pass that vertical line test. There was an assignment, the first assignment over functions, we had something like this drawn, and it was one of the things that said, tell if this is a function, and the answer would be no. Do y'all remember why something like this, a horizontal parabola, wouldn't be a function? Well, vertical lines intersect it more than once. So here, since we're looking at functions, and we'll be looking at functions the rest of the semester, we're only looking at parabolas that open up or down. No left or right, because if they're opening left or right, it's not a function.
Realize also when you're graphing them, there'll be a tool for, these are called vertical parabolas. There'll be a tool for a horizontal parabola. Well, we're not graphing any horizontal parabolas because they're not functions.
But every day when I drive to Del Mar College, there's streets I don't turn down. They're there just to confuse me, okay? I got to know which street to turn down, or else I have GPS on and it'd be telling me that. But don't let the fact that there's some tools you don't use, it's just there to confuse you. Now, also on that first assignment over parabolas, we said that the domain are the numbers that you can plug in for x and not get an undefined. Well, we had the rule that if you have an equation and there's no square roots and no fractions, the domain is all real numbers. Okay. I'm going to start doing problem number 9, but if we were going to graph these things on paper, you've got to know that vertex. And then you need 2 or 3 other points. Generally, well, 1 or 2 other points, a total of either 2 points or 3 points. Generally, if you just know one of the other points, then whatever's happening on one side is just a mirror image on the other side. And that's how the graphing tool is going to work. In order to graph a parabola, you're going to fill in this table. Plug in minus b over 2a, and that gets you the vertex, xy. Then, just any other number, other than whatever minus b over 2a is. Any other number. And we're going to start problem 9. Just showing right here. It says, graph the quadratic function. I specifically chose number 9 because 7 and 8 are just like this, except the numbers are a lot smaller. And then give the vertex, axis, domain, range. So let me write that down. This is problem number, you know what, maybe I have room to do it right here. Number 3. f of x equals negative 3x squared minus 30x minus 72. And the first thing it says to do is find the, well, it says graph it, but in order to graph it, you've got to find that vertex. I think the first thing it wants us to do is to find the vertex, and once we check that, I think at that point it'll give us the graph to draw, okay? But, let me flip over here. Let me lift this up a little. To find the vertex, I'll use this vertex formula, which is also, oops, you know what? You may not be able to tell this is green, but this is a green line that cuts it in half. It's the vertex formula. It's also the axis formula, and I'll demonstrate that in a minute. So we start off with, if you have to memorize this, the way I suggest is if you have the quadratic formula memorized, then let me see. If you have the quadratic formula memorized, it's just the quadratic formula without any of the plus, minus, square root and all. Here we go. I'll write down minus b over 2a. And help me out. A is negative 3, so we know how it opens. Is it going to open up or down? Down, because A is negative. B is a negative 30, so be careful. There's minus B, that negative, I claim that's going to make it a positive 30, over 2 times A. 2 times negative 3 is that going to be a negative 6? So let's see, what's the x-coordinate of this vertex? Positive 30 divided by negative 6 is, not hard, I'll get you started, negative 5, okay. I'll draw my XY table. Plug in a negative 5. That's going to get you the vertex. The vertex you got to type as an ordered pair. You can't just type in negative 5. Instructions say type as an ordered pair.
I think this is number 9.
Oh, why did I write 3? I'm sorry.
Blame the students for that.
No, I'm never going to correct
you.
Okay.
Bad teacher tips. When you make a mistake, blame the students.
Okay. And he's choking there.
Of course,
that was my mistake.
I like to write out here beside that negative 5, vertex.
Oh, yeah, I did it there and I forgot to right here. But okay. Let's plug a negative 5 in for x. Negative 5 times negative 5, that would be 25 times negative 3. Is that a negative 75? Then plug in a negative 5 in for this x. Negative 30 times negative 5, what's that going to be? It's a positive what? Negative 30 times, oh, you're punching it in, well, I think it's going to be a positive 150. Mm-hmm. And then a minus 72. What's that going to turn out to be? Negative, oh.
It's a
3.
A negative?
Yeah. Yeah, it's a negative 147 plus 150, so 150 minus 147. So that's the vertex. We'll go ahead and type that in right now. Notice the vertex is an ordered pair.
So we type in.
It says type an ordered pair. If you just write negative 5. Now it says to go ahead and graph it. Well, in order to graph it, we've got to have another, oh my gosh. Oh, okay. Let me get another point.
Now, this graphing tool works like the absolute value tool we used in that assignment several weeks ago. You plot the vertex, and then you plot one other point. So now Tony's found the vertex. He needs to find another point. And the reason I'm showing this graph, though, is realize whatever point you use has to fit on that graph. What's my favorite number to plug in for anything? 0. If I plugged in 0, I'd get negative 72. So if x is 0, y is negative 72. Look at this messy graph here. I don't think you can get down negative 7. You can't go down 72 units. The furthest you can go down is 20 units. So you got to make sure the point that you choose yourself will fit on this grid. I've found that you shouldn't go more than just 2 units. The vertex is negative 5, negative 3. You can plug in negative 6, negative 7. Or you can plug in negative 4, negative 3. But you got to choose an x value that's within 2 units of that x value of the vertex. Otherwise, your point may go off the grid. So choose an x value that's close to negative 5 as the secondary. What do y'all want to use? I couldn't hear you.
Negative 3, okay. So now we're going to plug negative 3 in. So let's see. Negative 3 squared is 9 times negative 3, negative 27. I'll race you, Tim.
Well, with my arthritic
negative
fingers,
30 times the negative 3, is that a plus 90? Minus 72. What are we getting for this? That's a negative 89. No, a negative 99. Is that going to be a negative 9? Oh, Tim, I think you've done something wrong.
Negative 3 times negative 3 squared minus, that's a 30 times negative 3 minus 72. So that's a negative 27 plus 90 minus 72. I'm getting a negative 9.
Yep. Okay. So that'll be on the graph. Again, theoretically, the easiest number to plug in would be 0. You wouldn't need a calculator for that, but it won't fit on the graph then. That's another reason I wanted to do this problem as the example.
So I'm going to come over here, and I'm going to hide that thing there. And let's see, I got to say enlarge the graph. And now, let's choose the graphing tool. Well, it's sure not going to be that looks like a line tool. That V, I remember those V's. Those were absolute value, V for value. Here it is, the U-shape. We have a vertical parabola tool and a horizontal parabola tool. Are we going to be using that horizontal parabola tool? No, it's vertical parabola. And notice when I clicked the tool, the first thing it says to do is plot the vertex. So what was the vertex?
Negative 5, positive 3. And you have better eyesight than me, Tim. I couldn't.
There. Is that negative 5, positive 3? Are y'all looking at that that yellow box on top? And when I click there, notice, gosh, this is so. Back in 1982, when we started at Stephen Falstead State University, and there had been something like this, would have been science fiction. And now, once we plot the vertex, it says plot another point. Well, what was the other point that we got?
Negative 3, comma, negative 9.
Negative 3, it's over. Is that it?
Yeah.
Yes, there it is. Save it. Oh, look how nice that looks. Now they want to know other things. I want to know the axis. Remember, the axis is just that the result you got when you applied that vertex formula, x equals negative b over 2a. Then notice that what you type it as an equation. You can't just type negative 5. You have to type, what was it? X equals negative 5.
Remember, x equals a number is a vertical line because every x value is negative 5.
And that vertical line passing right through the middle of the parabola. The domain, we know the domain. Every quadratic function has the same domain. No fractions, no square roots. The domain is?
I'll get you started. Parentheses.
Okay, I was wanting them to say all real numbers.
Oh, I was wanting them to say negative infinity to infinity.
Negative infinity to positive infinity. That's fine. Yeah. Because that's what you have to type in.
For every one of the problems like this, 7, 8, 9, when it asks you for the domain, you put in negative infinity, comma, infinity with parentheses.
Now, for the range, you have to look at the graph.
Now, the range takes some thought.
Let me see what I can do here. No, let's see if I can do it right there. There it is. Is the vertex corresponding to a maximum y value or the minimum y value? Is that the high point or the low point on the graph? Maximum? What is that maximum y value? What was that y value right there at that vertex? Was it 3? That's what it looks like to me. So the biggest y value on this blue graph is 3. There are no numbers up, there's no graph up here, so there's no y values bigger than 3. What about every number smaller than 3? Is it going to be used as a y value? I'd say yes. As a matter of fact, I think it would be used twice.
If you use keep those, if you drew the arrows like you were drawing earlier today, it keeps going down, down, down. Is it going to hit the floor? Yeah, it's going to hit the floor, not the ceiling. So we're going to say the range is 3 to what? Positive infinity or negative infinity? Negative infinity.
But remember, with interval notation, you must put the smaller thing first. So what's going to go first? Negative infinity to 3. What it goes in front of? Oh, wait. Move it up.
It's going to show both. Write it like this and then like this, which one's right. But you've already given it away, so I just marked it out. There.
Negative infinity has a parenthesis, but 3 is used. We have a point on the graph where the y value is 3. So you have a bracket at 3. But you always put a parenthesis in front of a negative
and
infinity.
This is a very poorly made infinity symbol. Looking at this, one semester, a student asked me, is it true to say that when you're looking at a vertex, this first number is always in the axis, and this second number is always in the range? And I said, yes, that's a true statement. In general, if the parabola is opening down, the range is negative infinity, comma, the y value of vertex.
Bracket.
It's a bracket there. Okay? That's what I'm trying to write here. Negative infinity to 3. If, on the other hand, the parabola had opened up, you would have the smallest value being the y value of the vertex, and it goes up to infinity. So if it's opening up, the range looks like this. Y value of vertex, comma, infinity. And I forgot to punching the answer there? Are we finished?
No.
Oh.
Negative infinity minus 3.
Any questions there?
The vertex will correspond to the maximum or the minimum value of the function. By that I mean the maximum or minimum y value on the graph, depending on whether the parabola is opening upward or downward. Oh, this is about as well.
Here's number 10, deals with this idea of maximum and minimum values. And I want to shoot, it says, the figure shows the graph of a quadratic function where y is a function of x. Use it to find the minimum value of f of x.
Remember, f of x is the same thing as y. So you're looking for the minimum value of y that's on the graph. What's the smallest y value on that blue graph? I'll blow this up. What's the smallest y value on there? 6. That y coordinate, it's hard to tell, but that x coordinate there is negative 6. The negative is hidden within that bar there on the graph, that line on the graph. But the thing they're trying to point out is that the maximum or minimum is not the x coordinate, it is the y coordinate. So 6.
I just wonder, that's that. If we click here, does it make it easier to see? Maybe that makes it, maybe once more.
Hey,
There.
I think that looks good.
I still can't tell the difference. That still looks like a 6, 6, but it's a negative 6, 6. Okay, well, we haven't had a lot of word problems this semester, and y'all have been asking, demanding more word problems, so you get your wish today. And in these word problems, you're going to be given a quadratic function, and then it's going to ask you something about the maximum or minimum. As a hint for these word problems, find minus b over 2a and plug it in. You'll answer the question even if you don't understand the question, okay? Every one of these word problems, and there's a whopping 3 of them, you have the, you're given a function. Where's my mouse? Oh, let me go ahead and write this one down. It's number 11. A woman has a taco stand. She's found that her daily costs are approximated by, notice, instead of an f of x, this function is called c of x for cost. X squared minus 20x plus 660. Where c of x is the cost in dollars to sell x units of tacos. So x is the number of units of tacos. That doesn't necessarily mean it's just the number of tacos. Who knows what a unit is? It might just be one taco, or maybe it's 3 tacos, or maybe a unit is a dozen. Mm-hmm. Okay? Find the number of units of tacos she should sell to minimize her costs. Well, how do we even know that we're going to have a minimum? This is quadratic, so the graph's going to be a parabola, but let me flip over here. Remember how I said you can tell if it's opening up or down based on the number A. On our problem number 11, what's that number in front of the x squared? It's a positive 1. So, is this thing opening up? So it does have a minimum. So I'm just making sure that this problem isn't some trick question where there is no minimum. If it had been opening downward, it better ask about a maximum, or else it's some sort of trick question. So, if you find minus b over 2a, and then plug that number in, it's going to answer the question. So a is 1, and b is negative 20. Don't forget that negative right there. So minus 20. So a negative is a positive. So the little, I'm using a red pen for the negative 20, and that's why I'll put that like that. Negative from the formula, then another negative becomes positive, all over, 2 times A. We can do that in our head. What's 2 times A? 2. So what are we getting for X? It better not be negative. It wouldn't make sense for our answer here to be negative. You can't have a negative units of tacos. Let's see, what's that? 20 divided by 2. Is that a 10?
So is that $10?
No, that's 10 units of tacos.
Whatever unit is.
What, you want to type that in?
Mm-hmm.
Because that's the first thing it asks for.
She should, if she's trying to minimize her total cost, she should try to sell 10 units of tacos. The minimum cost is, when she sells 10 units of tacos, how do we find the y coordinate? What are we going to have to do? So you have the x coordinate of the vertex. To find the value of the function there, you
plug it in. Oops, not a 20, a 10. I'm sorry. Let me rewrite that. So plug a 10 in for x. Let's see. 10 squared. That would just be 100. Then a minus. 20 times 10, do y'all want to help me out there? 200. And we still have that plus 660. So 100 minus 200 is negative 100, plus 660 is 560. And that's dollars. Wow. It cost her $560 to make her 10 units of tacos. I assume that a unit is not just one taco. Okay? If she's going to have to, if she's spending $560 in order to make her 10 tacos, there's a big problem there. Okay?
That means that she better be selling those tacos for over $56 a taco.
So it might even be more than just a dozen tacos.
I would think maybe 100.
Yeah, maybe 100. So the minimum cost is $560.
That means that there'll never be a day that she goes and opens up her taco stand and she spends less than $560 to operate it. She has to buy supplies, she has to pay for her employees.
She has to pay rent. Perhaps the taco stand is located inside a business, and if she gets a lot of people going in there, they might say, okay, we're not going to charge you any rent today. Okay? Because they just want the traffic, the people walking in buying her tacos. So that's why, like, if she had made no tacos, how much would it have cost her? If X was 0, could y'all do that in your head?
She didn't make any tacos.
Or she didn't sell any.
She didn't sell any tacos. It cost her $660. Well, wait a minute. But here, she bought supplies to make these tacos, and it only cost her $560. If she doesn't buy supplies, it's still going to cost her $660 to make those tacos.
Well, rent.
Someplace they're going to charge her more rent because
she didn't get anyone go into the business to buy the taco. Okay? So, y'all see what I mean? Do minus b over 2a, plug it in, you'll answer the word problems. Even if you don't read through all the words. Here on number 12.
Oh, this one applies given the number of mosquitoes here in Corpus lately.
The number of mosquitoes, M of X, in millions in a certain area in Corpus Christi or South Texas depends on the June rainfall X in inches. Well, that would be easy. There was no rain in June in Corpus Christi.
It all came in September,
Yeah.
right?
Find the function that models that. No, the function that models that phenomenon is. So, m of x is a 6x minus x squared. This is actually a very tricky function. And then it says, okay, find the amount of rainfall that will maximize the number of mosquitoes. What is the maximum number of mosquitoes? The fact that it's talking about a maximum leads us to think it better be opening down. Is it opening down? Is A negative? At first glance, you might say A is positive. No, it isn't. This should be written with the x squared first. We're going to write this as negative x squared plus 6x. When it's written with the x squared first, is it clear that this thing is opening down? Because A is negative 1 and B is positive 6. So we're going to go minus B over 2A. X equals minus B over 2A. Let me lift this up. So minus B, so a minus 6 over 2 times A. That's still something I can do in my head. 2 times a negative 1 is a negative 2. So what are we getting here? Negative 6 divided by negative 2 is it 3? So just aren't asking because I'm asking too. Y'all aren't answering because my questions are too easy on me. Negative 6 divided by negative 2, positive 3. So with this function that some scientist dreamed up, if they have 3 inches of rain, that's going to maximize the number of mosquitoes. So you'd be hoping for either more than 3 inches or less to get fewer mosquitoes. What am I going to do with this 3 in order to answer what's the maximum amount of mosquitoes? Plug it in. And where's my calculator? I'm going to pull this calculator up. And I'm just going to use it as it's written right here. If I plug a 3 here and here, I would have 6 times 3, well that's 18, minus 3 squared is a 9, so 18 minus 9 is 9. So if there's 3 inches of rain in June, then they can expect 9 million mosquitoes in the area. Okay. Ooh, let me do that. 9. Any questions? Even if you don't understand, well, why are they trying to maximize the number of mosquitoes? It seems that they should be wanting to minimize them. Well, based on that function, you can't minimize them. I guess the fewest mosquitoes you could ever have is how many? What's the fewest number of mosquitoes we could have in this room right now? 0, right, okay? So I guess that's why they don't need to minimize mosquitoes. The fewest you could have is negative. It's 0. You can't have a negative number of mosquitoes. So, last one. This is our last word problem, so it's going to have to be the hardest one. If an object is projected upward from ground level with an initial velocity of 32 feet per second, then its height in feet after t seconds is given by. Instead of f's and x's, notice this is written how you see a lot of functions in physics. This is called a position function. is going to be telling us how high that object is at any given second. T stands for seconds. While we're using a T, it's time. Negative 16t squared plus 32t. Well, it's opening down, so there is a maximum. So we want to find the number of seconds it'll take for the object to reach its maximum height, and then calculate the maximum height. So in words, what am I going to do? Well, find the minus b over 2a and then plug it in. So let me write. I'll do it like this. T equals minus b over 2a. Hey, I didn't label a and b, so let me do that. A is negative 16, b is 32. So we have negative b. So on the top we have a negative 32. Oh, what are we going to get on the bottom? 2 times negative 16. Is that another negative 32? Oh, so that object isn't going to be going up very far. It's being projected up, thrown up or something. After 1 second, the object's hit its maximum height and starts falling down, falling to the ground. So we plug in a 1. A lot of times students say, oh, they don't like word problems, and they just skip them. But this isn't anything difficult. Just look and find the function, do minus b over 2a, and plug it in. Oh, heck, can we plug that 1 in without too much trouble? Plugging in the 1. Can y'all do that even without a calculator? 1 squared is 1, so we have negative 16 times 1. So negative 16 plus 32 times 1 is 32. Negative 16 plus 32. What am I going to type in here? 16. So it's not going very high up based on this function. Whatever thing it's being projected up or being thrown up in the air, it goes, after 1 second, it's 16 feet up in the air, and then it starts falling down. Okay? Oh, let me check it. Oh gosh, I wonder if we'll finally get touch screen things here. Not just spend all your life looking for it, not all your life, but spend your time looking where is the cursor. Okay? Any questions on any of those 3 word problems? Minus b over 2a, plug it in. Okay? This was a small class today. Well, with the rain, students don't want to come, and besides, they can watch the video, can't they? Okay? Are there any questions on this? So then I'm going to stop recording, and then if you have a question you want to ask that isn't recorded, then ask away. Ooh, right. Ooh.